Good afternoon, CET 103 students. Welcome to the uh, construction surveying series. And today I'm going to discuss vertical curves. Uh, I hope to you that you have done the reading in the textbook on vertical curves prior to this. As far as vertical curves, we're simply going to touch the surface of them today and explain a little bit about the vertical curve and the vertical curve process and why an engineer would use it in the field and how it would affect us as surveyors and surveyors who are going to be laying out a vertical curve in the field. So I hope to explain to you at least a few of the key components of vertical curve and possibly how to read some of the curve data and the information from a set of plans so that you could maybe effectively lay out a set of curves. I would, however, request that you investigate further if you were to lay this out, because they are a complex part of the construction surveying layout process and the engineering design. So I'm going to recommend that you actually seek advice prior to laying these out and working with your professional. I would ask that you just you see this as just kind of an exposure to how to get familiar with some of the aspects of that. So what I'd like to do is start out with a screen share here, and I'm going to use the modified construction surveying slides, and I'll be using slides 32, 33, and 34, which will complete the series on construction surveying. You should have had these already up in your course information. You can look them up if you'd like to follow along. And then I also ask that you refer to the textbook on the section on vertical curves. So while we're talking here, let me go ahead and open up my slides so they'll be a little bit larger, and let me go back here to the first set of slides. Now, many of you may remember in the previous slides up to today, we've been talking about horizontal curves, and I guess the best way to think about vertical curves versus horizontal curves is a vertical curve is one that is in which we take into consideration the elevations of the road. And I guess the best way to think of, I like to use the little analogy that the horizontal curve you would see in the plan view of a set of drawings. Imagine that as the bird's eye view as you were looking down over the project. If you remember the previous set of plans, I showed you a little bit about the highway that's just below the university campus there, west of the university campus. And we looked at the way that Highway 47 peeled off and there was an off ramp. And that was we saw the aerial photographic imagery in which we were able to look directly down on the project. That was horizontal curvature. Well, in our project now, today, we're going to be talking about vertical curvature. So there are two very distinct separate curves and separate types of calculations. They're not to be confused with one or the other. Now, there may be a vertical curve and a horizontal curve happening in the same place in a construction process, or they may overlap each other or do things like that, but they are not the same pieces of information and they should be looked at differently. So you would look at your horizontal curve in your plan view. You would be looking at your vertical curves in your profile view. So if you like to look at it this way, let's talk about the bird's eye view, looking down, horizontal curves. The worm's view, or laying down on the ground or the surface, being the vertical curves. Okay, so I kind of like to try to explain to you a little bit about what a vertical curve is. So if you can imagine, we have a highway here in which the highway, the center line of our roadway, is now going up, and then we reach a point where we're going to want to then change the grade and go over and turn down. I'm going to go back to some of my very crude sketching here, but I think this really will help you explain this a little bit better. So imagine we have the slope of a roadway coming in, and let's see, I'm going to come over here and try to draw in Mr. Minsick's truck here. By the way, these fancy sketches are all part of the class that you all are taking, so you don't even realize you were getting these fancy sketches. But imagine this as being a vehicle, and a vehicle being traveling this direction up this road. You can see that we've got a steep incline. Well, if we were to reach a point over here where we would want to go down the road in this direction, we would not want to come over here, cap out, and drop down over the other side. So in this situation, what we'd like to do is maybe transition from one road to the other like this, so that we could go up and down over this side. This is what we call a vertical curve. There are some key components of the vertical curve. One, there's a particular grade going into the curve. This is going to be symbolized by what we call G1, which is the grade going into the curve. And then there's G2 over here, which is the grade going out of the curve. So we'll be talking about those as we go in. So one would be a percentage, would be a slope going that direction. The other one would be a slope going the other direction. So you can see here, this would be that direction, and this one would be this direction. So in this situation, we'd have a positive grade going in, a negative grade going out. Now, how do you determine which way is positive or negative? It's really a function of stationing of the highway. If the highway is progressing this way as we go along, then this would be a positive slope going in and a negative slope going out. There are also some other components of this, and we will begin. I'm going to come back to this slide, so hopefully I can keep that. So I'm going to minimize, let's see, I want to see if I can minimize this and go to my next share right here and get back into my slides here. So getting back to where we were initially on the slides here, I want to talk to you a little bit about what exactly a vertical curve is. So vertical curves are used mainly in highway and roadway alignment. They're also used in railroad type alignment, where we're talking about the change in grade or change in elevation of something. There's basically two types of vertical curves that we deal with in the industry. One is called a crest. A crest is when we would be going up and then back down over something. The two examples that I've showed you would be an example of a crest where we actually, the stationing increased as we came up and then it dropped down over the side. The other type of vertical curve could be what's called a sag, and in a situation of a sag, the curve would be going in the other direction, where the incoming stationing would actually be dropping, and then as you reached a low spot, you came back out of it in a situation like that, which would be a sag vertical curve. So in talking about the elements of a curve, similar to what we did in the horizontal curve, I want to talk to you a little bit about the elements of a vertical curve. If you see right here, one of the key things that's very important in the vertical curve process is something that we call the PVC. If you notice right here is your point of vertical curvature. The next one is your PVI. Well, what is your PVI? Your PVI is your point of vertical intersection. You can see that represented right here. You also have your PVT. Your PVT, which is the point where your vertical curve starts to go back into a transition piece, and it touches the curve actually touches the tangent and goes back into a tangent piece. So therefore, it's called the point of vertical tangent. Also, two key important pieces of vertical curves is the grade going into a curve and the grade going out of a curve. That's going to be your slope G1 and G2. Uh, Another piece of data that's important in the computation of a vertical curve is something that's called the h, or this distance, which would be if we were to extend the tangent going in completely all the way to where the curve ended at the PVT station. This would be that difference in elevation between what is the point on the tangent all the way down to the point on the actual curve itself. That's this piece right here, or H. The point H right here and point PVI are really fictitious points in the overall scheme of things, because they're either above the construction process, kind of in midair hanging out there, or it's if in a situation of a sag, it would be underneath the process. So therefore, there usually aren't numbers that we use, or that's something we would physically lay out in the field, but it is something we would use in the computations and the analysis of our projects. So they are important calculatable items. So these are your probably 6 most important calculatable items. There are some others that we'll discuss in the next slides. The procedure for calculating the vertical curve. Now, there are several different methods of doing this. I'd like to spend a little bit of time talking to you about the process called equal tangents, where we're actually going to lay the vertical curve out in even equal segments along the curve process. So some of the things to know about laying out the vertical curve using the equal tangent process is that we have to have some curve data. In this situation, you'll see that we've been given the grade in, which is our G1, which is a positive 6.5%. G2, which is a negative 3%. So we're going up at a fairly steep grade and dropping down at a not so steep grade. We're also going to have the station of the PVI, which is station 14 plus 19. And we actually have the elevation also of that same PVI. And we'll progress on to the next slide. Okay, so here's what we have we have our first grade going in, which is our G1 going in. You can see that there's our 6.5% going in, or 0.065 per foot. You get that by removing the percentage sign, by moving the decimal place two places to the left. You'll see that this is a positive number going in. And here we have the PVC, the PVI right here, and the H, or the horizontal distance, or I'm sorry, the H, or this distance right here. So in finding the key components of a vertical curve, our vertical curve would come right here and go along this way and drop back here. What we would be looking for when doing a layout by equal tangents, we would actually be looking to slice our vertical curve up into pieces here, and then determine the elevation at the pieces. The concept for calculation of a vertical curve is actually fairly complex, because the vertical curve is, unlike the horizontal curve, is not a simple curve, it's a parabolic curve. So therefore there's a constantly changing radius along the way. So I encourage that you follow the processes and procedures, which will come at a later class, which will talk a little bit about how to calculate a vertical curve. But I do want to start with, how would you find the grade of the at least the beginning points and the ending points of this curve? So to find the PVC and the PVT elevations, we would start out. We know the PVI elevation, which is it was given to us as let's see, I think the elevation of the PVI was given to us as 12.29, or let me go back a slide and I can find that. Yes, it's 1,229.41 feet above sea level, and and it was at station 14 plus 19. So in a vertical curve, one of the things we have to identify is how big our vertical curve is. In this situation, we have what's called a 200-foot vertical curve. What that simply means is that there is 100 feet back horizontally from the PVI and 100 feet ahead forward from the PVI, which defines the PVC and the PVT. So therefore, the PVI station is 14 plus 19. So therefore, the PVC station would be 100 feet back, or the station of the PVC would be 14 plus 19 minus 100 feet, which would be 13 plus 19. So the station of the point of vertical curve would be 13 plus 19. How would you calculate the elevation at that vertical curve point? Well, we would calculate the elevation of that vertical curve point by finding out our grade going in. We had a grade of 6.5%. What this simply means is that's 6.5 feet per 100 feet, or 0.065 per foot. If we take the 0.065 per foot, multiply it by the 100 feet right here, we know that there is a drop from this point to this point of 6.5 feet, because it's 6.5 feet per 100. This is 100. So we would get the elevation of the PVC to be 6.5 minus the 29.41. Therefore, the elevation of the PVC would be 1222.91. So therefore, that is the elevation of our grade of where our curve is beginning. This is the elevation of our PVI. The process for laying out equal tangent curves would be then to sector the curve, or for a lack of a better word, slice up this curve in multiple sections along the way. In this situation, we would do it by 25-foot intervals. So there'd be a section here, a section here, a section here. What we would then do is, we would take the 0.065 per linear foot and multiply that times the 25-foot distance here. And that would be the elevation at which this point is going to climb every 25 feet. I would then calculate the elevations along the vertical curve, or the vertical line, this first G1 grade going in. I would calculate elevations at each of those points as we went through, all the way till I got to this last point right here. And then by doing the computations, and we are not going to be going into the computations in this class, but you would then calculate what is called the curve offset, which would be the difference between the straight line tangent and the point on the vertical curve. By computing that offset using the formulas provided, you would then be able to take that tangent distance and subtract it from the tangent distance to find the vertical curve as you come along here. This is an important element in the laying out of a vertical curve. Vertical curves are very crucial in the construction process and a very important part of the survey layout. This was a quick little video to kind of show you a little bit about a vertical curve process and help you to be familiar with the vertical curve. Again, just to recap, what we did learn along the way was we talked about the importance of the vertical curve. We talked about some of the important elements of a vertical curve, which is the point of vertical curvature, or the PVC, the PVI, the PVT. We also talked the key elements about the grade going in and the grade going out. We also talked about two very important types of vertical curves, which is the, excuse me, I'm going to go back to a slide. We lost our screen sharing there, so let me go back to our screen sharing there. And going back to our beginning slides here, we did talk about some key aspects of that, which is the crest curve, which is one which is the grade G1 is higher, is increasing positive, and then it goes to negative, or a sag where the G1 is negative going in and increases to a positive as it goes out. This is the process of vertical curves. So I hope this helps a little bit with this information, helps a little bit to understand vertical curves. I know it's a complex piece, but I did want to at least expose you all to vertical curves. I do encourage you to do the reading in the textbook. And I would like to finish off by going out and stopping this share and possibly sharing another screen with you here, which would be this one here. Some of you may remember this from our previous slides the other day. And what I'm going to do is I'm going to kind of capsulize here on this. And I want to call to your attention this particular piece right here. And if you'll notice right here, this is that piece of highway that I talked about, and it probably is best going to a bigger screen here. This is the piece of highway I talked about earlier, and this is the university would set up here, and this is a set of highway department plans of Highway 47. And this is the Jerry Murphy roadway intersection and overpass, as we see right there. This is the off-ramp coming from the university off onto Jerry Murphy Road. So this is the plan view of that, or defining the horizontal curve that goes to exist right here. But what is kind of interesting about this particular section, as many of you know, we're coming from a higher place up on the campus, on the hill up above the campus, and we're transitioning here in down back to a lower piece and then back up to the top of the overpass. So this was a situation where it was necessary to have a very large vertical curve where we have this is a sag situation where we have a positive going or a negative going down and a positive going out. Actually, this particular curve process starts because stationing increases from the left to the right here. It actually starts over at the overpass and actually transitions down as it goes back onto the highway system. So this is a good example of a vertical curve. This is found in your plan view. Here you find the horizontal curve information. In the profile view, you find the vertical curve information. I hope this helps to share a little bit of some of your questions you may have on vertical curves, and this will end our series on vertical curves. Thank you, and I look forward to our next section on construction surveying. Thank you. Have a good day. Stay safe, and we will be sharing other information with you. Thank you and good night.